prior to actually building materials, we have to have a good starting point. We have to have a neutral calibrated scene, so our materials can be, and their properties can be observed without any interference from light, color, or other materials or something like that. Because once you will be constructing your scenes, every material will interact with other material. It will collect a bit of color from it, a bit of shininess, a bit of all kinds of data. So you might end up, as generally most of the users end up, is creating materials per scene basis, which can sometimes work, but it often leads to results where you put, for example, some value in the color channel and you get different results in the render, and that's a nightmare. That's really problematic to get something decent out. For example, one would put a yellow color in a shader, and due to some many factors, the object would become maybe orange, and a whole lot of problems then pop up. That's why I always suggest creating a calibrated scene. This scene will be calibrated by eye, but it's really good enough, and I would really encourage you to build your materials in neutral scenes, so you will exactly know what that material is, looks like, and what will it look like in some other scene. In any case, you will be sure that you are correct about your material settings. Let me show you how you will calibrate this scene. For example, here we have a simple sphere and a plane and a simple area light with a material here. And that material has a pure white color with a 100% brightness and full RGB value. The 255 is the maximum RGB value. And this may sound okay, but in fact there is a problem with it. There is no object on the planet that can reflect 100% of the light and be pure white. The maximum white value for the brightest piece of paper or any material you can find in the world is 95%. Let me enter that here. And this will give you the value of 242. So we will use this maximum value for our calibration point. Since most of the users will always go for realistic materials, maybe a portion of them will go for highly stylized and artistic materials, but then those rules don't apply, and generally those materials are really easy to pull off. So I will concentrate on realistic materials. We close that. For a realistic behavior of the material, you have to have a realistic behavior of the light. So here under area light, I will select under its fall of type to inverse square. That's how the light behaves in the real world. And you can instantly see there is a big difference in intensity of the light in our scene. I'll later show you how to tweak all these light parameters to get really great results from the render. So if you do a test render now, we'll see that this scene is blown out, way out of proportions, and even the most new user could observe that. So this is way too bright. I actually want to render this into picture viewer by pressing this little guy here, or Shift and R, and I will get a small window. This is in fact a very powerful feature here. It's called a picture viewer, where you will be able to do any sort of stuff with your scenes. You could even later play with saturation, brightness, and so on. We will cover that in later lessons. Currently this image is too small, and you can see here it's 320 times 240, and that is way too small. We want it to be, let's say, a double of the size, so we can actually see some things going on. So here in the render settings, under output, instead of manually duplicating this, I will select this lock ratio, so this will simply drive the other value, regardless of which you choose, to keep the ratio. I'll just type here times 2, and I will get double the size. So if I try the render now, press Shift and R, I will get double the scene. There are many options here. Here you can delete the scenes. Nice little trick about this, if you press down the Control key and hover, you will see some values changing down here. So you can see here, it says 255 free times. So that's the RGB value. So observe this value and see how it changes. So it's almost all 255. So scene is way burned out. We have to get the 242 value in the most brightest part of the scene. That would be somewhere around here on the sphere. So let's tune down the intensity of the light first. Let's try 50% for starters, and press Shift and R. Now we have somewhat different results. So let's try to measure, and it's 255 again. So we have to lower the intensity more. So let's try with something like 40 maybe, and do a Shift R again, and we will get a new render. Try to find the brightest point, and it's 225, 6 maybe. So now we have to increase a bit. Let's try maybe 45, render again. And we're getting closer, we are around 250. So let's try 43, render again. Remember to hold down the Control key, and now we are good. So the brightest part is 242, you can see it down here. And it's all good. And now we have a calibrated, standardized scene for creating our materials. So for example, if we would change this to something like this, let's say 200 by 200 and 200, you will get some gray results, and maybe just to add some color to it, say 50 here. Now if we would test render it and find the brightest point, it would not exceed 200 by 50 by 50. So what you put in here in color channel, and the color is almost always the most prominent feature of the material, will come out in this calibrated scene. So you will be sure that material is completely correct, and once you apply it to some scene you built, you will know that there is a problem with lighting or problem with other materials and so on and so forth. This scene calibration, let me just delete that, is so often overlooked by users. And it's so powerful, it is so simple yet so powerful, and it will give you really endless possibilities in creating really realistic materials. So let's go to our next lesson.